Hello, everyone. Welcome to yet another CIIR talk series. We have Professor Chirag Shah with us here, and he has proudly wore his CIIR t-shirt, which we are really proud of. So it's my pleasure to introduce Chirag. Chirag is an associate professor at the IS School at the University of Washington, and he's also an adjunct associate professor the Paul Allen School of Computer Science and Engineering, as well as Human-Centered Design and Engineering at the University of Washington. He is the founding director of the Info Seeking Lab, and he's also the founding co-director of the Center for Responsible AI Systems and Experiences. He's been an active member of the IR community for a couple of decades, and he has been publishing in the IR venues and HCI venues. And he has also been active in industry as kind of joint appointment or during the sabbatical at Spotify, as an Amazon scholar, and as a visiting researcher at Microsoft Research, and more recently at Getty Images, where he works on building task-focused search with relevance and diversity constructs. And he is also a recipient of the Karen Spark Jones Award in 2019. So today, Chirag will talk about fairness, bias, and transparency in search. So please join me with a round of applause to kind of virtually welcome Chirag to UMass.
Well, thank you. Thank you for that introduction, and glad to be here. This is quite a treat for me to come back, at least virtually, to alma mater, and especially, no offense to the rest of the UMass, but it just feels special to come back to CIIR. And yeah, so this was not by accident that I, wearing this shirt. I think I also have maybe CIIR mug somewhere. So it's so good to see some of the familiar faces. And what I thought I'll do, because I actually struggled, what would I talk about here? Because obviously, I can't really lecture you on IR stuff. You guys know way more than I know. I can talk about some of the user-centered IR that I've been doing since leaving UMass. But then I thought maybe, I would really speak to the students, because looking back when I was a student, what would I like to tell myself, not back in 2006 or 5 when I was a student, but if I were a student right now, what would I like to tell myself? And so I thought I will really address this talk to the current students, and I can definitely use some help from non-students. And so I'm structuring this talk not so much as, oh, we did these things and we solved these problems, but hey, we're struggling with these things. And it's not just our struggle, but those who are really serious about IR should also be struggling here and should also be having these questions. So that's why I'm actually titling this with this question: can these search systems be fair? Can they be actually unbiased? And why or why not, right? And so what I'm hoping is having people actually question this with me and help me out, right? So I just, as a disclaimer, that I haven't figured things out, that even when I present some results, some ideas, just know that there are shortcomings, there are serious problems with it. One of the things I was recently talking to a colleague of mine, and we discussed these things about responsible AI and how do we mitigate some of these problems, that we saw that we are talking so much about fixing the problems that could have been avoided in the first place. And so we're saying, well, we shouldn't be surprised that these things happen, because these are the students we are training, and then they go out and they're doing this thing. So really the blame is on us, that we should be thinking about how to better train them. So we're thinking about the next generation of students. who would be trained with this thing, who would go out and would have this thought process as they're building solutions and whether they go in academia or industry. So that's sort of my intention here, to at least encourage us to think that way. And so again, the questions, and I've structured this around the questions. So what are some of this bias and fairness problem that I talk about? And chances are you probably already know some of them, or many of them. Where are these coming from, right? And some of these, again, they're obvious, like, yes, that's where the bias is coming from, but there are some that are not so obvious. Of course, we want to think about what do we do about them, right? And as I said, the current state of our work, most of the work is really fixing the existing problems that we already know. But really where we want to go is, how do we make sure that these problems don't happen, or we have a better control over those problems in the future? And so I think this is where I would like us to think more about what is so difficult about this. Why are we not able to just like flip the switch and have things done? Yeah. All right, so just to kind of give a quick introduction of what problems I'm talking about, because again, these may be things that you already know. So many years ago, and many of us now even forgotten that there are these systems for doing travel booking, systems that look like this, where a travel agent, so you had to be a specialist actually, this wasn't a very user-friendly interface. You had to be a specialist to search and find the actual connections and so on, and so people have got trained in it. Well, there was a system that would provide the data for a travel agent to do that searching. But at some point, they started giving higher weight to some airlines that would pay this company, right? And so that's kind of, is that really fair? Is that good? Because now you're getting things that are biased in a way, and the bias is coming from who can pay more to get their results highlighted or coming up at the top of the rank list. So this was one of the first examples that we know in the modern world, modern time, in bias and ranking system. And one of my current colleagues, Batya Friedman and Helen Nissenbaum, they talked about this. This was in 1997 on this idea of computational bias, where there's some kind of discrimination is coming in a system that's favoring some group and unfavoring some others. Now, people can argue that, well, this is not a new thing. Grocery stores have done this for ages, right? So they have power over placement of products. So they can place certain products at on certain height, certain visibility that gets most kind of access, easy access, and they can put certain things, too high or too low. And they get to decide because it's their store, right? So even though they're selling somebody else's product, so in a way, this has kind of been there, but systematic bias like this in a computational system wasn't really explored much. And then of course, you fast forward many, many years and decades now, and you see examples like this, where you're looking for CEO in image search and you see mostly white men. Now, the thing is, many CEOs are actually white men, but the idea is, is this okay? Because people are getting all these perceptions from searching through things, and what they're taking away from it is it's CEO means white man. There are a lot of other works, and we can have a whole presentation just talking about that, but the point I'm trying to make is these things are now omnipresent. They're there in not just our ranking, but also in our recommendations, right? So this is an example of autocomplete, is a famous book by Safia Nabel, Algorithms of Operations. So there are a lot of these things that are happening, they're starting to happen. The question is, where are this coming from, right? And so they're coming from all kinds of sources, all kinds of ways. The first thing, which is often hard for us to accept, is that, we are all biased, and even good people. So we're not biased because we are bad people or anything like that, but it's almost like evolutionary, and people have talked about it, how we carry certain biases and prejudice. But then that gets reflected in the data sets we build and the systems we build, right? So some of these things are often hard to accept, that we can all be biased and any data set can be biased, any model can be biased, that there is no perfect data set, that there are always issues with the collection and analysis of data and so on. But this happens so those are sort of more obvious. This happens in less obvious ways too. So if you look at the click-throughs in ranking on Google, you see that the top result gets clicked a lot, and then the click on the next result drops significantly, and so on. So by the time you get to result 10, it's barely anything, right? And most people are not even going to the second page or third page. Why is this bad? I mean, this is what, in a way, we would expect, right? This is good because that means we are getting the most relevant results right at the top. It satisfies the user need and they're happy. They don't need to really even scroll down to the first page. Well, it's not that simple, because people have this kind of a belief with that top ranking. They believe that if it is showing up at top, then it must be true. So there's a disconnect between relevance and truth, except that for most people, that's not the case. So here's an example. This happened a couple of years ago where somebody posted a picture of the spider and started making claims that this is a deadly spider. One bite can kill you. And it has already killed a bunch of people in West Virginia, Tennessee, Mississippi. And this was shared, I believe, it was Instagram or Facebook, quickly went viral. And then, of course, people are looking it up, right? They're looking up deadly spider. And so in Google, you can see the search trend, the spike that you see here, that's right around that time when this post came out and went viral. Before that, nobody really cared much about deadly spider, but then there was a spike on deadly spider related searches. Now, when you do that search and you retrieve it, you look at the top 100 results, and and we did this where you can say, well, okay, what are the topics? What are the subtopics in that? You come up with something like this, right? So you can see the different circles or ovals about the news on spiders, the stories about dangerous spiders, first aid. But the biggest one you see is the sharing and discussion of the original post. So the one that was on Facebook, that was actually fake news, but it got shared, it got discussed. And so most of the results that were coming up in the top 100 on Google were those results. And if you look at the top 10 results, which is what most people are going to see, that's the shaded portion, right? So the rectangle is the all 100 results, and then the ovals are the different partitions of them. The shaded oval is what most people will see. So you can see that even though there are some results about fact checking and other news on spiders, what most people got exposed to was, again, the same fake news and the resharing and reposting of that fake news and discussions and so on. So it's not just simple as relevance. People tend to associate these things with truth, and then they keep talking about it, and then algorithms in the back end are learning that it must be a good thing because a lot of people are clicking on it. So those things keep propagating even higher. Now, there's a reason for search engines to do that, the algorithms to kind of do that, because, well, first off, hopefully everybody understands search is expensive, right? To build it, to maintain it, to innovate, it's not, it's very hard for a startup to do a search now. Ads are a primary way for paying for it and generating revenue. And so you have to ask, why would somebody give you ads, right? They're giving you ads because you're going to bring them impressions and clicks, right? You're going to, these ads are often based on how much engagement you derive from your users, how many monthly active users, daily active users you have, and so on. So a lot of the ad placement and the payment for the ad is based on that, which kind of makes sense, right? I mean, if you're the ones running the ads, you don't want to put your ads someplace where nobody notices. So The more people notice, the more people interact with it, the good. And so you want to increase engagement. That's sort of the primary objective. So that the ad has the value. Well, what generates engagement? How would you increase engagement? Well, the simple answer is give people what they want, right? Now, when I was in grad school at CIIR, and then we talked about these things, and we immediately associated with relevance, that what people want is relevant information, and that's what a good IR system should do. Well, that's, again, not as simple. People don't simply want facts and information. We know that they tend to be more engaged with different emotions, right? So these things have, again, we have seen the effects of it. Emotions of hate and fear, they generate the most amount of engagement compared to other emotions. In a way, we have kind of known that in news realm. A lot of the news stories that the negative kind of things, they actually get more discussion, they get actually more consumption and so on. So in a way, it's not a new phenomena, but we've definitely picked it up and intensified. And also conspiracy theories, right? So here's an example, and this is like a dated example, so it's probably not true anymore, but this is on YouTube where for the query related to NASA, you get recommendations for videos that are pure conspiracy theories, they're fake news. But you see in the last column, the engagement, that first video has 11 times engagement, and it's recommended, and the algorithm learns that this is the right thing to do 11 times more than the actual NASA related videos and so on, right? So even when people are looking for NASA or looking for videos, they see these things, maybe they're in the recommendation, maybe they're in the ads, but they're a lot more likely to click on it. They generate engagement, and the backend system is going to learn that things related to NASA are these, because obviously people wouldn't be clicking on them if they were not relevant to their need. But again, relevance notion is very diluted now. Okay, so how do we address this? Given that there is a mess here, right? There's biases in data, in our algorithms, people behave this way, they have this engagement. And then we have all this large scale search systems that are designed around increasing engagement. Not that there is anything fundamentally wrong with it, but we know that engagement, we tend to do more engagement around things that are not necessarily factual or relevant, but they're entertaining and have other values. So there are a lot of efforts, a lot of ways, not just us, but many others, have been trying as a way to address bias and bringing some fairness so that people have exposure to better information, different information. So we often hear about diversity, novelty, doing information exposure, different exposure, trying to quantify fairness. What is fair? How do we think about fair? How do we capture it? How do we serve it, and so on? So what I'm going to do is I'm going to tell you a little bit about our effort and what worked and what didn't work. Yeah. So we said, okay, well, one way to reduce bias or bring some fairness, and here in this case, we're kind of directly associating fairness to bias, right? So fairness means lack of bias, but that's not always the definition or case. How do we do that? Through diversity. And so here's what we did, a very simple thing. You take a query, you take the top results, say top 100 results, you identify what are the subtopics in it, right? So that spider example I showed, it had half a dozen subtopics, but we just stuck to 2. And then we said, okay, well, let's re-rank these top 100 results so that there is a fairer ranking. Now, what is a fairer ranking? There are 2 kinds of fairness we consider. One is statistical parity, where you say every group, underlying group, should have equal representation, and disparate impact, which says the representation should be equivalent to their actual size, right? And I'll come to that in a minute. This work was done with my former student, who's now at Amazon. We had some papers, excuse me. So we used a couple of data sets. We used some data from Google. We used some, I think this was for track data from New York Times. And as I said, to simply keep things simple, we just did 2 subtopics. But of course, you know, the top 100 results could have other number of subtopics. These are some of the, excuse me, queries from Google Trends. You know, so this is in 2019. So these are some of the queries that were kind of trending at that time. Okay, so now I'm going to walk through as if, you know, I'm teaching a class. How do we do this? So we have top 100 results. So on the left here, you see our 10 pages, each with 10 results. And we want to just come up with the top 10 results in by doing some form of ranking or re-ranking, sorry. And let's also say that the top 100 results belong to red class or blue class, right? So these are the 2 subtopics that we have identified doing some kind of cluster analysis. So how do we do that? If we are doing statistical parity, which says that you should have equal blue and equal red, then you can do something like this. If you're doing disparate impact fairness, then we know that there are 70% blue and 30% red. So in your top 10, you should have 7 blue and 3 red. So by statistical parity, fairness, you need 5 and 5. By disparate impact fairness, you need 7 and 3. Of course, this is not what you actually want to do because you know, this is not a clustering problem or classification problem. This is a ranking problem. So rank matters. So how do we do this? So we take so for the statistical parity, you need 5 blue. So we take the 5 blue in the order in which they appear in the top 100. And we need 5 red. So we again take the 5 red in the order in which they appear. And then we maintain that relative order and create the top 10. So you still get 5 blue and 5 red, but they're ranked according to their previous, you know, relative ranking. Similarly, disparate impact, same process, except that you're looking for 7 blue and 3 red and relative ranking. So now you get, you meet your criteria for fairness and you're maintaining the rank order. Okay. The one issue with this is we're taking subsequent documents, so we're not introducing as much novelty. Maybe we want to optimize around novelty as well, right? So right now we're kind of digging vertically. How about we also dig, you know, horizontally? So we do the same thing, but now instead of going down vertically, we go horizontally. We're looking for 5 blue and 5 red. And again, we organize based on the relative ranking. So now we are sampling up to the first 5 pages, right? Similarly, disparate impact, we're looking for 7 blue, 3 red, and we present this. So we're meeting the fairness constraint, but we're also exploring the space. In one case, it was more vertical. In the other case, it's more horizontal, right? But one could argue that that's also not good. That's also not enough because now we're kind of just skimming through the top. Maybe we need to do both. We need to do both down and sideways. So we did this version of Epsilon greedy algorithm. And so here's a simple kind of explanation for that. So Epsilon is a small value between 0 and 1. And that gives us a way to explore. So with probability of Epsilon, you explore, and with 1 minus epsilon, you exploit. So if epsilon is 0, then essentially that's your default. Like whatever Google or whatever search engine gives you, that's it. No exploration, no changing, just what it is. Epsilon 1 means you're kind of just doing random exploration all around. But in most cases, we do something else, right? So here's a simple naive algorithm with epsilon greedy, where you say with some value of epsilon, randomly select from the top 100. And with 1 minus epsilon, pick from the top. So we typically set epsilon, say 0.1, right? So with 0.1 probability, you are going to pick something from the whole top 100, but 0.9, You're just going to pick what Google gave you, right? So that's a very naive algorithm. The fairness focus epsilon greedy says, well, we want to do the exploration. So exploration is, fine, but the exploitation we want to do based on what fairness criteria we are trying to satisfy. Okay. So with probability epsilon, so this is the measure of exploration. You pick a cluster. So you got two clusters, you pick one with that probability, and you pick the top one from that cluster, right? So this is your coin flip in a way. This is where you're randomly picking something. But 1 minus epsilon, which indicates exploitation, for that you want to say, well, what cluster should we pick that will help us meet the fairness criteria, right? So going back to statistical parity or disparate impact, right? So statistical parity will say, make sure you got 5 blues and 5 red. Have you gotten all our 5 equal number of blues and equal red? No, then which one is lacking? Let's go to that cluster, right? So that's how you pick the cluster as opposed to kind of random. And then that's where you do the exploitation. And so again, the only difference really from the naive epsilon greedy and the fair epsilon greedy is that you're considering trying to meet the fairness criteria while doing the exploration. So what we find is, yes, we can actually improve the fairness or lack of bias here. We can just set epsilon to high value and do the random exploration and try. That doesn't necessarily work. And in fact, we found that through this technique, we can also actually improve relevance. So Jeremy, who's on the call, may be actually familiar with this idea that there are times when there are good, relevant documents that are at the bottom of the list or somewhere down that people don't get to. So through this exploration, we're able to bring some of those up. And so it also actually increases relevance in some cases. And here's going back to that example we were looking at before. So on the left is the original one where you have this partitions of different stories about spiders. And then the shaded region indicates the top 20 results, the top 10 results showing up. As we work through this fair greedy algorithm, you can see, so we're not able to change the configuration of the partitions or what shows up in the top 100. But if we re-rank, we're able to shift that graded region. So now it also starts covering some of those fact-checking stories and news from reliable sources and so on. It still covers those fake stories or the misinformation, but we're able to bring in some diversity, giving users at least a fighting chance to see other side of that story, right? And when the hope is, if people then start clicking more on those fact-checking thing or somewhere they're debunking this original post, then the underlying algorithm will learn that maybe that's actually relevant or engaging, so it starts bringing it, and then this the shift happens. We also thought it would be interesting to see the user side of it. And this is another thing, like I'm in information school, and so we care about the user side of it. So what I just showed you was just the back-end side where we algorithmically show something, positive happen. We said, well, does this actually make an impact on users? Can we test this? So we designed this game called Google or Not. The idea was to essentially have people play a game where on one side, there would be original ranking from Google, and other side would be the ranking that we generated through our epsilon greedy algorithm. And we just asked them which one you like, right? So essentially, and we randomize the order and all that kind of stuff, right? So it kind of looked something like this. So there will be a query at the top and then 2 rank lists. You don't know which one is from Google and which one is our re-rank, and then you pick. Turns out that most people can't tell the difference between the original Google results and the one with epsilon 0.3, right? So that's a good thing, because that shows that the user satisfaction remains the same while there is more diversity introduced. Yeah. But of course, if you push it too far, then people start noticing, and then they will go with the default Google list, because other seems not as relevant or not as good, right? So, but we learned that we can actually introduce some diversity without sacrificing relevance or satisfaction. So this seems a really good thing, right? And here's me now, being honest with you that sure, that part is good, but there is a side effect or a dark side of it. Turns out that the same technique can be used to seamlessly introduce misinformation. So we did the same thing, this time now with COVID-related stories or queries. And when we did this, some of the stories, some of the things that were actually, debunked, fake news thing, they also started making their way into the top 10. Okay? And unfortunately, as I said before, we found that up to Epsilon 0.3, people couldn't tell the difference between original or the good one and the one with that diversity introduced. So the lesson here is, sure, diversity helps, and you could actually fool people up to some point, and that's a good thing. That it's, this is like my wife, sneaking, vegetables in our kids' meals, so that if they don't notice and if they eat it, that's great. And you don't want to push your luck too far. But the same technique can also be used to introduce some other harmful things in it, and people don't notice it, and they get exposed to these things. So it's not as simple. And that's why, before I told you about all this ways people are addressing issues of bias and fairness, and there's merit to it, some of the things we've tried, but there's a cost to it. And some of them are kind of quite negative effects that we already understood, that sometimes bringing diversity or novelty could reduce some of the relevance or utility. Sure, maybe we can sacrifice some of it if we really care about diversity and lack of bias and so on, but that's a cost. We may also have to sacrifice some of the personalization that, because often hyper-personalization makes things biased, right? It creates filter bubbles. So these are some of the challenges with that. We of course lose out in engagement, and there's also danger of misinformation. And then it becomes a question of who watches the watchmen. So Bing had this feature called Bing Perspective. I think it's kind of still around, but certainly not in a prominent way as it was before, where you are, say the classical example is coffee good for you, right? And so there are two perspectives to that. There are benefits of coffee, and there are harmful things about coffee. So it makes sense to kind of maybe learn, if you're really interested, curious, to learn both sides of it. But then you search for, is Earth flat, right? Now, there are two sides of it. Most people know Earth is not flat, but there is still, the flat earthers and the flat Earth theory. So then the Bing perspective will bring up both of these things. Was Holocaust fake? Right? So again, there is no shortage of people denying Holocaust. And so then would you present both of these as perspectives that here's the thing supporting that Holocaust was bad and horrible, and here's the things that it was fake or whatever, right? So again, it becomes a tricky thing for a search engine to be able to do, even though with the good intention, right? So because it's not as simple as just diversifying our information sources and opinions and so on. So now we get to the core of this. Why is this still difficult? I mean, there are some, again, obvious reasons why this is difficult, but there are some really deep problematic things here. And I can think about many sets of issues here. I'm going to just divide it up in this three. There are measurement-related challenges, there are cognitive issues, and there are philosophical issues. And again, this is where I'm going to start leading to hopefully some discussion among ourselves here. What are some of these challenges, and how do we kind of deal with it? So here's an example from 2016, the US presidential election. And so what you see here is the top 20 election-related stories on Facebook, right? And these were actually manually tagged to indicate if a story is a mainstream news, so it's coming from one of the media sources, or is it fake news where people are making things up or it's not reliable source. And so what was found here is that as the election day approached, the engagement on mainstream news decreased and the engagement on fake news increased. So by the time you got to the election day, the rankings had rankings in terms of engagement had reversed, right? So regardless of how things were ranked in the top 20 things, if you look at just engagement, what people are clicking on, what people are sharing and talking about, the fake news was higher than the mainstream news, right? And now think about it for a second. And again, I keep going back to this notion of engagement because it's so important. That's where a lot of our business objectives are designed, right? So all this, we talk about the big search, who's going to pay for it? Well, ads can pay for it. Who's going to give the ads? Well, you need engagement, right? So think about the engagement here, that in the top 20, people are more engaged with things that are fake news. We've seen things even recently, and again, this is just intensifying even more, that there's a lot more engagement on false and misleading information about COVID-19 than actual reliable sources things coming out of CDC or WHO, right? So engagement, that's where we keep coming back to. So in grad school, we learn about all these ways we measure the effectiveness of an IR system, and those are really great. That's wonderful. And again, as a student, I learned these things. But then we learned that there are these other measures also that are important, right? Is what we are doing good? Is it right? Is it fair, right? Is it fair to everybody? What is our notion of fairness? So there are all these social measurements. And then of course, somebody has to pay for this, right? So there are these business measurements, objectives, right? And so that goes back to that idea of impressions and clicks and engagement and monthly active user, daily active users, retention, things like that, because ultimately that's what is going to allow you to have people coming back, paying for either their subscription or advertisers paying for the ads and so on. So we have and these things are often in conflict. What may be relevant may not be engaging, right? What may be fair may not retain your users. They may not come back because you're giving them, and then again, we found this in our experiments too, and many other places where giving them that kind of diversity may actually turn them off because they think that they're getting all these things that are not as relevant to them, or they're not as personalized to them, or and so they start associating it with lack of relevance. So these measures are often in conflict. So this is one of the challenges. Here's another challenge, another set of challenges actually, that these biases, there's a vicious circle. So as I said, we are all biased. We carry our biases. In fact, we talk about this, that for all these decades of AI system developments, we didn't stop to ask the kind of data sets we were using to build all this foundational models and techniques, that they were highly biased, but that wasn't something that came up. And so now everything got built on top of the same thing, and we kept showing the improvement on those baselines and so on. So those biases have already been built into so many systems we design and so many data sets that have been in circulations for decades now. But then there's also cognitive bias. People tend to believe things that they see at the top of the list a lot more, even if it is not true, or even if it is, has issues of, partisan, different biases and so on. People tend to believe in that. They tend to click on it a lot more. If, and then we hear this often in our user studies and stuff, if they don't find it on Google, it must not exist. But they didn't actually do their due diligence. They are not going to the second page or third page. They're not reformulating queries. Often they don't even know how to construct good queries, right? So then there is this immediate assertion: if I didn't find it on Google, it must not exist. If I found it on Google, it must be true. Same thing with Facebook and so on. So there are these biases. On top of that, as I said, we tend to engage a lot more with stories that induce certain kinds of emotions, typically negative emotions, fear, hatred, and so again, those things go back into the system, having them learn that this is the good thing to do, right thing to do, and so on. So that feeds into the algorithmic bias and so on. So there is this vicious circle that's really hard to get out of. And finally, I will mention this as I will put this in philosophical issues, but this is kind of becoming more important as we see large language models and other kinds of foundational models, right? So I'll quote Creel et al. Here, looking at using some of these foundational models and how do we use them for scaling. And what are some of the challenges with that? So a couple of things I'll point out. There's actually a lot of interesting points there, but a couple of things I'll point out. One, what they call the homogenization, right? Which is algorithmic monoculture. So this big model that is done using this Common Core or other, large corpus, it essentially tries to represent the world, except that it is one view of the world, right? So that's what they refer to as monoculture. And that could lead to arbitrary rejections, misclassification, and ill treatment of individuals and subjects, right? And it has the potential to amplify biases that have already existed. Again, we are all biased. Our data sets, they're built, the things that we've expressed over the decades and maybe centuries are results of those biased views. These models, if not carefully implemented, can amplify those biases, right? And they can compound them, making it very difficult to then debug and solve. So there is a lot of discussions. I mean, one of my colleagues here at Emily Bender, we've been talking a lot about some of these large language models and the implications, and foundational models and implications on future of IR and NLP systems. There are a lot of progress shown. There's a lot of excitement. There are a lot of cool demos, and I can see just before this talk, I was actually in a meeting with Microsoft Research folks, and again, there's obvious excitement about some of these things, but they also admitted that there's a disconnect between a cool demo and then what may actually happen. And often those demos are misunderstood as, yeah, we solved the problem, why not? So including the demo that I not demo, but the results that I showed, it seems like, yeah, we finally figured out how to do FAIR and bring diversity and so on, but it's not, it's actually much deeper than that. So often it's easier to get the surface level results. Google has shown some of those demos recently. If you've been watching, Lambda, for instance, also the, what is that, the multimodal, starts with the M. There are several, of these, large language models related things, but there are deep issues with this. And as I mentioned, one of my first points is, as we are training our students, as we are talking through this in an education context, we're deeply concerned about missing this out now, and then years from now, trying to fix the problem the way we are trying to fix now. A lot of this problem is introduced over the decades of AI development. Okay, so I think there are some just philosophical issues with it. Finally, I want to just give my thoughts, a couple of thoughts on what do we do about this. And obviously, this is where I want to encourage everybody to participate and talk about, like, where do they see both the challenges and maybe some possible solutions. So I'm going to divide it up, and I'll just give just one quick example for each of these for how some of these things can be more in a sustainable fashion can be addressed. So the first is we can think about bringing some innovations in the way we build models and report. And again, I'm looking at our students, right? So there are these classical ways we report our results, and which typically goes as significant test done on this and in this table and this graph and so on. Here's an example, which is inspired by nutrition labels. So you see the nutrition labels on all our foods that we purchase, and that allows, it gives the transparency. It gives somebody to actually compare things and understand what's in it. Is it perfect? No, but it's a good way to communicate and be transparent. So Meg Michelle and her colleagues proposed this idea of, it's called the model card. And this is, it's okay if you can't read all of this, but you kind of see an example of what it looks like, where it's really transparent about how a machine learning model is built, what kind of data it has used, what are the underlying characteristics of that data, and so on, right? So this is, and you can also see the ethical considerations and caveat and so on. So changing our practices in the way we teach these things, present these things, talk about this thing, that could be really, really impactful here. Another way, of course, again, because we're in education, so I strongly believe that we all have responsibility here as we teach this class, as we attend this classes, to ask these questions about not just how do we improve the performance of some AI system and how do we achieve that accuracy and so on, but really to think about the values behind it. So I'm pointing out this book by, again, my colleague Batya Friedman and also Dave Hendry. We have a VSD lab here, which is world famous. They focus on value sensitive design. So they're looking at issues of not just bias and fairness and stuff, but general ethical issues that span multiple cultures and many times multiple generations. They're looking at things that are many of us not even thinking about. They're looking at multi-generational design, things that are not just what's now and tomorrow, but for generations to come. The same way we think about climate change, and it's not just to address some issue right now, but we think about coming generations and the impacts on them and so on. So there are things we could be doing, or some scholars are definitely doing, but more of us could be doing is really using our position for first educating ourselves and then our students, and then being advocate for this. So not wait till the problem happens, so again, similar to climate change, and then we are trying to put out the fire, in some cases literally, but what actions can we take so that these problems don't happen? And I think those are the things we should be asking. And finally, and this has also come up many times now in conversations, that a lot of these systems, they have very little incentive to change their practices. And sure, there's regulations that can happen, but first off, regulations not keeping up with these issues and challenges, litigation sometimes, but really one way which we have done in other industry is to have auditing, right? So I'll give you an example of auditing. For instance, if you now query Google search for CEO, you will see something like this, which is very different than what I showed you in the beginning, right? So that screenshot was taken from a couple of years ago where this discussion happened. And of course, it got a lot of media attention. So it seems like Google has fixed this problem, right? Because now you don't see just white men, except that if you were to modify your query a little bit, then you will start seeing again similar thing. And in fact, if you go back to what Google is showing, how do I, oops, okay. Where you see non-white men, you can kind of see that those are actually stock photos, not real people. I mean, well, they are real people, but not real, maybe not real CEOs. So it's very easy to kind of bypass that by doing something like this, right? And so this is a simple example of adversarial attack where you're able to show the flaw in the system by trying, something like this. And so we've been doing this Here's an example. Well, we've done it with other search engines too. Google, Naver, Baidu, and Yandex. And not just the CEO, but what you see on the x-axis are different professions. The y-axis indicates how far, in terms of the proportion of images you see, we are from the reality, right? So for instance, you see the nurse, right? So we looked at the actual distribution of nurses in male and female gender in the US, and what you see on the search results. So this is, the higher means worse because they are far off from the true distribution. Truck driver, for some reason, you get a good, match up to what it is, right? Biologist, you get a big, and so on. And then I'll skip this because this shows like, okay, well, we applied the fair greedy algorithm and we were able to reduce some of this bias. But what I want to kind of now start wrapping up is seems like there have been progress made, absolutely, but there are still issues, and some of them are too big to be addressed by a single group or single project or single year. There are technical issues, there are business issues, there are social issues, and often they're in conflict with one another. You make progress in technical side, and which is what often we are concerned with, but then you get stuck with the business or social. So we're continuing some of the efforts here at UW in different collaborations that at least I'm involved in. One of the projects I want to bring up is also with the CIIR alum, Yangfang Zhang, who was a postdoc there and now is a assistant professor at Rutgers. So we have an asset project on explainable recommendation system. So there are, of course, and these are just some of the things that I'm involved in, but there are lots and lots of efforts going on across the United States and around the world. I want to bring last couple of points here that these large-scale search and recommendation systems have these issues. Some of them are technical and some of them are business. There are ways we can fix the existing problems, not fix, but mitigate at least, right? By auditing them, by creating this re-ranking or some additional layer on top of the existing. But I think what we should really be focusing on is a longer term impacts, and that's where education becomes very important. Advocacy, how do we kind of bring this discussion from day one rather than let's just first build the solution and then we'll figure out how to fix the social issues or so on. So I think that's where our conversation should be. So I'm leaving you with like a negative thought in a way here that these things are still not enough what we're doing, and we need more work here, more education, more involvement. And so I'm sorry, I took up longer than I thought, but I really wanted to hear from you. What else can we do? So let me stop here so that at least I can take a couple of questions or comments or suggestions. Thank you.
Great, thanks, Chirag. Interesting talk. So we had quite a few questions in the chat. So I start reading them, and if they require kind of clarification, I'll ask the writer to kind of unmute and explain. So the first question is from Howlun Bu. The question is, may I ask, how do you measure and conclude that user satisfaction will not be influenced with the re-ranked ranking list with epsilon equal to 0.3?
Yeah, so that was a good, thanks for the question. It was a very simplistic study that we did where essentially the satisfaction was associated with which one you like the most, right? So two rank lists, which one would you pick? I mean, similar studies have been done to compare different search engines where you get a rank list from, say, Google and a rank list from Bing, which one the question is often phrased differently, which one you trust the most, which one is the most relevant, which one you like the most. We found in our experiments that most people can differentiate, and this is actually a bad thing, but they can't differentiate between which one is the most relevant, which one is the best, which one you like the most, which one is most satisfactory. It's completely or very highly correlated. And so we asked just that question. And so from the HCI standpoint, one could argue that that's not satisfaction we are measuring. And I agree. But as I said, we found very strong correlation between these terminologies.
Okay, thanks. So the next question is from Chloe is it possible to develop robust evaluation metrics for misinformation, bias, hate speech? Let's say we have a knowledge graph of statements with things like the Earth is not flat, or the Holocaust happened, or etc. You could imagine a metric uh, that explicitly seeks out various known types of misinformation in adversarial attacks, an evaluation based on the rankings of the misinformation relative to the textbook information.
Yeah, great question. So this is where a lot of discussions are currently with the large language models. Can they do this, right? And the surface evidence suggests that they should be able to. But that's why we have been digging deeper into this to see if they really understand that, like, the question is, why is Earth being flat a misinformation? Why is that wrong or bad? And the way a lot of these things are, so mums, and this is what I was forgetting before from Google, and similar models, they seem to be doing intelligent things. But if you dig into that they don't actually have an understanding of this. They happen to just be looking at these things that are co-located, where somebody has said that Earth being flat is actually just is wrong, it's debunked, and so on. So they're picking those things up. So it is possible to do this, but we are at the mercy of having that kind of data. And this has definitely been proven to be problematic. So one example I'll give you, and there are many actually. Somebody asked, there was this question, and you can look it up now. Which is the ugliest language in India, right? And Google answered Kannada. And I don't know if anyone here is from India or know enough. And it picked it up because of these associations. So these language models are currently not being able to, like, if it was a human being would have said, that's a stupid question, I'm not going to answer that, right? It's an unanswerable question, or it's a bad question. These models are not able to do that. So what we are finding repeatedly is that no matter how much knowledge generation and capturing you can do, you still need to have a process that actually interfaces with the user to eliminate some of these poor choices. Because otherwise, you go and ask something here, something will definitely come out, including what is the ugliest language in India. It shouldn't have happened, right? So yes and no, that's my answer.
Okay, great, thanks. So we are out of time, but I wanted to take liberty to kind of continue asking the questions in the chat, because I think one of the most advantages is just these kind of interactions between the audience and the speaker. So I'll go and ask this next question, which is from Chris. Information access systems operated by for-profit companies always optimize for user engagement, which can introduce multiple forms of unwanted biases, as you mentioned, such as misinformation, political bias, anti-competitive bias, and etc. Do you think that this situation can change by introducing some form of regulations and transparency for ranking algorithms? Or the only way to optimize for factuality and usefulness is to rely on open systems and large-scale explicit feedback from people?
Yeah, I see that question. Thank you for asking it. So I mean, again, we can all have our personal opinions. One thing to note is information access system for the most of the history have been considered a public good. So this notion of large corporations doing this is a fairly recent one. I know we kind of all grew up with it, so we just took it for granted. But if you actually trace the history, you notice that these things, and this used to be libraries and educational institutions, that they were there as public good, institutions, and not driven by profits. So there were definitely good things about it. Can we now, it's maybe you can say impossible to go back to that model where these institutions are run as a public good thing and not commercialized. The question is then, but can we use regulations to do something like that? Regulation can definitely help. I don't think it's going to solve the whole problem, because as I pointed out, there's this vicious circle of bias. So the bias is not introduced by just simply these algorithms or this company is trying to cash on engagement, right? We are hooked onto that. We as the users, we want to, like, we love seeing this cat videos and conspiracy theories. Not that anything wrong with cat videos, right? But it's not going to be fixed by just regulation, right? It will help. And Europe is a good example of where some of these things actually have been helping. The US, we are kind of behind. And so it'll be interesting to see where what we do. The FTC recently adopted a similar framework as the European Union about the AI systems. And it's not exactly for bias, but ethics in AI systems. So I think, and then many companies have internally, as I said, I was just talking to Microsoft, and they have their internal guidelines and principles on AI ethics and so on. Those are baby steps. They're still welcome. But I don't believe that just these things will fix the big problem. I think we need multi-pronged approach here. And that's why I kept emphasizing education, the role of education as well here.
Okay, thanks. So the next question from Yashin is, you might have mentioned, but how do you reduce bias generated by large-scale pre-trained models practically? Is fine-tuning enough?
Good question. So I don't think there is a good accepted practice right now. This is a conversation. One of the suggestions is to make sure, so these, like, the foundational models are meant to be kind of a one-way thing, right? Where somebody has built this, developed this, and now others can take advantage of them. So they don't have to, like, they can work with the pre-trained models, that they don't have to do this thing. But if they find any issues with it, currently there's no easy way to propagate it back and make the changes for the rest of the world. So one of the solutions is to reflect, like making it a two-way street, where these things that you find in your actual applications, that not only you're fixing it, but you're actually propagating it back to the pre-trained models. I haven't seen good examples of it. Maybe somebody has. But I would say that fine-tuning, and this is in a way what we were doing, right? So taking the Google results and re-ranking it, or doing this adversarial attack kind of thing. So yes, those could fix problems on the surface. So as long as you have a very specific application, you could actually mitigate these things in that space. But this is kind of a, you know, like putting a coat of paint on a problem, and so you're just kind of hiding away the problem. So I mean, maybe that's what you're interested in, that's fine. So if you're not interested in actually fixing the problem, just you know, putting a coat of paint, then sure. I've seen good examples of that happening.
Okay, thanks. And I'll ask the last question and we can finish up. So the last question is from Bruce.
Can I jump in, Harman?
Sure.
Hey, Bruce.
Hi.
Are you in Massachusetts or Florida?
Right. A couple of quick questions. Well, comments. Information retrieval is a field that has a long history of, actually, as you mentioned, it has worried about different aspects of relevance and utility for many years. So it's always been a long discussion and lots of serious work done on the different things that make information interesting to people, as opposed to artificial intelligence in general, machine learning in general, which hasn't worried about that stuff at all. So please don't always lump us in with AI as having ignored all those issues along the way, because we haven't. Second comment is, a lot of what's going on, to me, seems to be being able to differentiate sources of information. So there's, you talking a lot about topical diversity, there's also diversity across sources. So for example, it would be trivial for them to differentiate in the search results between social media results and other types of results, right? And that would, then people could make their own decision about what sorts of sources they tend to believe or not. And if we could keep Wikipedia clean, for example, then that would be a fairly good source of good information. And just being able to, just a minor interface thing, basically to combat garbage in, garbage out, extremely old problem. That's another comment. The third one is a question, which is how is your approach different to standard diversity algorithms like X-quad or proportional representation? Because it seemed like a very diversity-based approach you were taking.
Yeah, thank you. Thank you for all the comments and questions. One thing I would say though, in terms of your comment, the previous one, while people can do this, they can sort through things, they can filter things, they don't. Right. So
I'm not talking about people. I said the search engines need to, it's a combination of vertical engines. They just need to differentiate it on the interface. Say, here's the section which is about from social media. So take it with a grain of salt, because this is all coming from
that would be ideal
who don't know anything, as opposed to from Wikipedia or some other respected websites.
Yeah, but we haven't seen that, right? So that seems like a fairly simple
they haven't
solution.
seen it, but I'm just saying it's not that difficult to do.
No, it's not, but it's still not being done. Some of these things are fairly simple to implement, but
so do some user experiments on that type of diversity in the interface.
But to your question, so the diversity actually, I just showed one form of it. Which is a topical and introducing topical diversity. But I agree. So there are actually many other sources of diversity. We have experimented with some of them. Source diversity is one of them, to highlight, say government resources or the commercial or the .org, those kind of things. I think I have some. I don't want to say skepticism, but certainly I see the limitations in simply relying on diversity as a way to fix this, because we also know the limits of the diversity. How far you can push before people realize that this is not good. I've seen this in, like I said, Spotify. In diversity recommendations. It also depends on the users. Some people really don't want to see anything different. They're very tied to it. So you also have to think about diversity with respect to personalization. But I'll have to think about your actual question of how is it specifically different.
I was talking about the specific algorithms, whether you did comparisons in your experiments to the standard diversity algorithms.
Yeah, so we looked at the fairness in two ways, right? So I think what you're saying, the proportional representation is similar to the disparate impact. So that way it's similar. The statistical parity is different. And we found that in many cases, statistical parity fairness does better than the disparate impact or the proportional representation.
Okay, well, that's just a knob. But anyway, I'll talk to you about that later.
There is also the third one, which we haven't tried, which is the disparate treatment. So then you give extra, give extra consideration to underrepresented, because historically they've been underrepresented. So you overrepresent them now, which is
and then you're getting into how much should computer scientists do social engineering?
Yeah. So I think that's a whole, so we haven't experimented with that, because that's a very, the affirmative action related things, that's very different.
Okay, great. Thank you all. Thank you, Chirag, for the talk. Thanks everyone for the nice discussions and questions. So let's once again thanks Chirag for accepting our invitation, giving this talk. And